in really jumping into the program today, we have just an amazing honor of being able to welcome one of my colleagues from Columbia Business School, a researcher, a professor, a named professor at the School of Business, Professor Lichtenberg, who has led this area of medical technology innovation research over the last 3+ decades. And looking forward to hearing him open up the session today and talk about how medical technology innovation has in fact been the cornerstone and where it's been adopted and how it's grown and what leads it to growth. Professor Lichtenberg, Frank, thank you for joining us today. I appreciate your time. I'm handing the virtual podium over to you. And you are on mute.
Thank you, Stan. Hope you can hear me now, and pleasure to join you today, although this is, of course, a very solemn day. This is a program on digital health and strategy, and I'm going to make some remarks that are maybe a little more general. A lot of my research and teaching is about the economics of value creation and medical technology innovation. And I put that in a slightly different way. And I think this all falls into the area of health technology assessment. So I'd just like to give you my little roadmap of what I think is involved in HTA, health technology assessment. For digital technologies, as in other medical technologies, we often have a new treatment or technology, and we want to perform an economic analysis of it. We want to determine the cost effectiveness of a new treatment or technology. And I would like to distinguish between two concepts. There's comparative effectiveness, which is often what is assessed in a clinical trial, but there's also cost effectiveness. That's sometimes called the fourth hurdle, because even though you might be able to demonstrate that your technology is safe and effective, the question is it cost effective? And that's sort of the central question in cost effectiveness analysis and health technology assessment. So, and I sort of divide that. My little roadmap has a number of different avenues. I would say one of the most important possible benefits of a new treatment or technology is increased longevity or life expectancy, or from another perspective, a reduction in mortality. That's the quantity of life. And that may be the most important and is certainly the best measured health outcome. But in addition to quantity of life or longevity, we're also concerned with quality of life. And there are a number of different ways of trying to measure quality of life. None of them is perfect, but I think they all have something to contribute. Suppose that we can measure both the quantity and quality of life that is attributable to a new treatment or technology. What we then need to do and can do is combine them into a single index called QALYs, or the number of quality adjusted life years. And that is sort of a measure of the health gains that result from a technology. But we need to often express that in dollar terms. So for example, a new treatment or technology may provide the patient with, say, 2 or 3 QALYs, quality adjusted life years. What is that worth? How much should society be willing to pay for that increase in QALYs? Well, then we need to get into the issue in what is the value of a QALY? What is the value of a statistical life year, as it's often expressed? And once we have arrived at an answer to that controversial question, we are then in a position to measure the incremental benefit in dollars of the new technology. So what is the new technology worth relative to the standard of care in terms of in dollar terms? Well, that's half the equation. The other half of the equation is to calculate the incremental cost of the technology. And that involves several steps. First of all, the list price is often not the net price. because there are frequently discounts and rebates that occur in the technology space. And therefore, we certainly need to account for those to measure the direct cost of the technology. But in addition, there are also indirect costs or savings. So for example, a new drug or a new diagnostic may reduce the need for other kinds of medical care, and therefore there are indirect cost savings. So those need to be accounted for as well in order to measure the net incremental benefit of a new technology. So those are some of the central issues that I discussed in my health economics course, and that policymakers are often concerned with when they're assessing a new technology, and payers as well, of course. Now, I would say that another important distinction is that there are two kinds of evidence that can be used to assess cost effectiveness. And those are not only randomized clinical trials, which are often considered the gold standard in medicine, but real world evidence. And increasingly, I would say a number of scholars have argued that real world evidence really plays an important role in the field of health technology assessment, that randomized clinical trials don't tell us everything that we want to know, and that in fact, real world evidence can add a lot. Well, just as an illustration of this, consider, for example, Merck's Gardasil vaccine. In 2006, Merck had developed a vaccine to prevent cervical cancer. And clinical trials demonstrated that the vaccine was clearly clinically effective, as the chart on the right shows, that a woman that was vaccinated, that was not vaccinated, had a 0.6% chance of developing cervical cancer, while a vaccinated woman, the probability was only about 1/3 as high. So clearly, this was, from a clinical point of view, extremely clinically effective. But Merck had to decide what price to charge for the vaccine, and that would influence how cost effective that vaccine would be considered by payers and policymakers. And so that is an important consideration. We examine that and do a full analysis of the cost effectiveness of the Gardasil vaccine and other medical technologies in the course that I teach, both in the full-time program in the business school, in the executive program, and in some of the digital health programs as well. So I hope I have the opportunity to interact with more of you in the near future, and to work together in this important field. So I think that's, I'm probably about out of time. I will stop sharing and turn it back over to Stan.
Fantastic, Frank. Thank you very much. Terrific way to kick off the Digital Health Symposium. Thank you very much.
My pleasure.
And again, Professor Lichtenberg, full named professor at Columbia Business School, on the faculty for the digital health program as well at Columbia Business School. Any questions, please either connect with me through LinkedIn or email me directly. I'll pop my email into the chat box as well. Next up, again, we want to pay tribute to Paul Farmer. He was a professor at Harvard. He was the founder of Health Partners, passed away recently, just this week, while in Rwanda teaching. And so we do want to have just a moment of silence here for Paul Farmer and the legacy that he's left behind in public health research. Again, just a tremendous legacy in public health by Professor Farmer. And we wanted to jump into another incredible person who's been contributing and in the digital diagnostics field now, and carry the discussion forward in digital health and in the realm of what we're looking at as a massively growing area around the diagnostics field. And really, I think one of the components that we're seeing from the diagnostics piece is this integration with virtual first healthcare and the need for more diagnostics at the home in order to ensure that we actually have a patient who can receive healthcare at the home without any issues of having to move to a facility unless necessary. And the pandemic has brought this on as a new form of healthcare delivery called virtual first. Glenn Tillman, who we'll be speaking with later on today about his $200 million raise for Transcarent, which is one of these new healthcare delivery mechanisms that are predominantly based on a virtual first mechanism. We'll be talking about this. And what we've seen is very much like managed care in the early 1990s, where managed care was just a small part of the healthcare ecosystem. Indemnity was really the predominance of healthcare delivery in the late 1980s. Over a 10-year swing from 1990 to 2000, we saw the healthcare delivery move from a predominantly indemnity system to predominantly managed care system. Roughly 5% adoption for indemnity for managed care in 1990 to all of a sudden a swing to 95% adoption for indemnity. And so this type of incredible change in healthcare took 10 years. CFOs for large self-insured employers, they didn't walk to the system, to managed care. They ran to it, they sprinted to it. And so what we're envisioning now, based upon some early signal noise from the nation's largest health plans and the adoption with large employers of those virtual first health plans, that over the next 10 years, these cost savings and the convenience for the patient, and it's important to remember that this is very much a patient-centric model. Patients don't have to take a PTO day to go to the doctor. They can do a 20-minute virtual visit. Patients don't have to take the hour-long car ride to the physician. They can now do a virtual visit. So the patient-centric model around the virtual visit is taking hold. The patients like it, the employers like it, the large health plans are trying to meet the need and the demand. And what does that mean when digital diagnostics and virtual first are leading the way in this new healthcare delivery model? And again, Glenn Tillman will talk about this, but what we're seeing over the last 2 years and over the next year or 2 years is now the development, very much like what we saw with finance, very much like what we saw with media, very much like what we saw with retail, is this new delivery mechanism for healthcare to be delivered virtually, and looking at how that will affect healthcare over the next 20 years. Will that now be the next 20 years of healthcare? The delivery mechanisms, the infrastructure that's being built over the last 2 years, over the next year or two, how is that being built up? And that's what we are anticipating. And again, this is not a revolution like the French Revolution that took place in a year or a day, but this is a revolution more like an industrial revolution, where you see the virtual first revolution taking place over the next 10 years. So by 2030, 2032, 2033, the predominance of visits will be virtual. There will be on-site and infrastructure involved when a physician needs to see a patient for the first time. These virtual visits are going to require that there is at least a face-to-face visit established, most likely. And there's a virtual first mechanism for this kind of piece to really as the starting point. But infrastructure for surgical procedures, for scans and radiology procedures, is we're looking, and we'll talk to a few of the major national lab providers today. Labs are being done now remotely, a good chunk of them at least. Prescriptions obviously have been moved closer to the home more than ever. And so we're now seeing this pickup there as well. Frank, if you're still on, talk a little bit about how the predominance of research in some of the papers that have been written lately around medical technology innovation effect, and how you see this virtual first movement and medical technology innovation converging as well.
I will try, but well, I mean, I certainly think that policymakers and others are very interested in assessing new technologies. What is often very visible is the cost of new technology. So we can see what the budgetary impact, the direct budgetary impact is. But what needs to be brought to their attention is also the benefits in terms of both longevity, quality of life, and also the budgetary impacts. It's frequently argued that that medical expenditures are often viewed in silos, and that's really not appropriate. That there certainly can be spillover effects, that investing in technology in one area can have consequences for other areas of the budget. And so I think that needs to be accounted for as well. And I think enlightened policymakers appreciate that.
We've got a question coming in from the audience as well for Professor Lichtenberg. How, when you look at RCT studies, how are they applied for surgical procedures?
I can't say that I have expertise on that particular area. I've done a lot more research on drugs, for example, and biopharmaceutical innovation. But it seems to me that the principles are really the same. That we always want to consider the impact on longevity and quality of life. We want to account for cost offsets. So while I'm sure that there have been many studies of specific surgical techniques, I am not very familiar with that literature, but it seems to me that the same principles would apply.
That's fantastic. Well, Professor Lichtenberg, again, thank you for joining us.